Hey,
Hello.
Zach. Can you hear us?
Hey, how's it going, everyone?
We're just talking about your legendary status.
Oh my goodness, please don't. Yeah, I spent a lot of time studying web fonts, so hopefully the next 25 minutes will be as informative as I hope it can be.
All right.
All right, we ready to get started?
Yes, let's get started. You can take it away now.
All right, great. So, as was mentioned, my name is Zack Leatherman. I'm Twitter, zacklead.com. You can read all my blog posts about web fonts. I have an entire section on there. So if anything seems confusing, you can go back and review some of that later, and I'll plug some more of that. So today we want to talk about web fonts, right? So web fonts are rocket science. The claim I'd like to try and convince you of today is that web fonts are actually not rocket science. It's much easier than maybe you might have previously thought. I got 4 sections to this presentation. We're going to talk a little bit about U.S. politician Mitt Romney. Sorry. We're going to talk a little bit about invisible and unstyled text, so the behavior while web fonts are loading, some font face block syntax, and then we'll go through some strategies at the end to make your fonts appear to load faster, quicker, render faster. So this guy, I don't know if anyone recognizes this guy, probably not. He's a US politician. His name's Mitt Romney. And in January of 2015, so I guess 3 years ago now, he was trying to decide whether or not he was going to run for the US president, So he was kind of going back and forth, couldn't really decide. And so eventually he did make a decision, and he announced it. And then Slate.com ran this article on their website, and it said, the headline read, Mitt Romney is officially running for president. And James Muspratt got a little screenshot of this, put it on his Twitter account. But the problem is that this isn't the decision that Mitt Romney had actually made. What happened was that Mitt Romney was not running for president. So this is what the website looked after all of the web fonts had finished loading. So while the web fonts were loading, a completely different message was communicated to the users that were viewing the website. So it's a huge problem for web fonts, especially for news companies, news organizations that really want very accurate content. They don't want inaccurate information to be communicated through their websites. So, and I'll go through a little bit more about why that happened later. But first, before we dive in, I want to talk a little bit about rocket science. It's aerospace engineering. It's really divided into 2 separate groups, aeronautical and astronautical. Aeronautical is things that fly in the air. Astronautical is things that fly in space. But actually, this is completely irrelevant. We don't need to discuss this too much because, again, the premise I'm trying to communicate right now is that web fonts are not rocket science. They're 2 completely separate things. Okay, so the next section I want to go through is just invisible and unstyled text. So what happens while a web font's loading? So web browsers have kind of chosen a default way to render the text while the web font's loading. The default behavior that a lot of web browsers use today is to make the web font invisible. The text that's using the web font is invisible while it's loading. Then when the web font finishes loading, it will re-render using the new web font content. And this is known as the flash of invisible text, so a FOIT. And this is kind of problematic, right? Because, and I love this tweet from Anand. He says that, remember when the text used to load before the images did on websites? It seems kind of crazy that this, the new web font behavior has kind of pushed text, the actual content that many people want to read on the website, to the end of the waterfall. So I think it's very important to sort of mitigate these problems. So one thing that web browsers have tried to do, another approach that some web browsers have taken, is to use something called the flash of unstyled text. So this will render your fallback font while the web font is loading. So this might be your normal sans serif rendering here, and then when the web font comes back, when it loads successfully, then it will re-render using your web font content. So it uses fallback system fonts while it's loading. And this is known as the flash of unstyled text, or FOUT. And this is kind of an oversimplification, but these 2 different strategies have kind of pit designers and developers against one another. for the most part, designers want to display a finished product. They want to exhibit control over their medium. And developers want to render a minimum viable product to the user as fast as possible. So how do we find a nice middle ground where we can make both parties happy? And it isn't a solved problem. There's not really a consensus right now. It's still very contentious. And you can kind of see that throughout the history of different font face implementations in web browsers. So back in 1997, the first web browser to implement web fonts was Internet Explorer. Hooray, Internet Explorer 4, nice job. And they actually used a full Flash font style text. So they rendered a system font by default to the users while web fonts were loading. And then a couple of browsers came along, and the next browser to implement font face was actually Safari in 2008. They went full Flash of invisible text. So all the web font text is invisible while the web font's loading. Chrome joined, Firefox joined. Firefox actually switched from Flash of unstyled text to Flash of invisible text. But they added something a little bit different. They added a 3-second timeout. So if the web font took longer than 3 seconds to load, they would render the system or fallback font. They would switch to FOUT, the Flash of unstyled text, until the web font had successfully loaded. And this is kind of a compromise that they introduced. And this is great, right? Because this created, this made it so web fonts were not sort of a failure, a single point of failure for your content. If the web font, the request hung, you may never see text if you don't have this fallback or this timeout. So Opera joined them, they switched, everyone is moving all around. And then a lot of browsers really kind of settled on this 3-second timeout. So it's kind of a compromise. But really the problem is that 3 seconds is quite a long time. It's quite a long time for invisible text. So let's just kind of sit here together and endure 3 seconds of waiting. And that's a long time to wait when your web font or when your web page is loading, because a lot of users might give up by the time 3 seconds of invisibility have taken place. And if you want to kind of play around with this yourself, I built a little Flash of invisible text, Flash of unstyled text comparison. You can check it out. Go to this website. I'll put these slides up later today. And you can kind of play around and it'll show side by side the difference between Flash of invisible text and Flash of unstyled text. So you can kind of get a feel for the different performance benefits of each. All right, let's talk about a little bit about lift coefficients. How many of you guys know about lift coefficients? They're great. Dimensionless units relates the lift generated by a body compared to the fluid density around the body, the fluid velocity and associated reference area. I'm sure you guys are all familiar with this, this formula here that's on the screen, but we don't have to worry about any of that, because web fonts are not rocket science. All right, let's talk a little bit about font face syntax. So, first thing we got to do when you have a web font is you might go out to find some syntax that exists already on the web. There's this bulletproof font face syntax that was really popular for quite a long time. And the thing what we want to do is just burn it to the ground because we don't want to use any of this. Well, that's not true. We'll actually use a little bit of it, but we can actually simplify this quite a bit nowadays. So we want to retire this bulletproof font face syntax. We want to move forward from the thinking that content fonts need to be served in all web browsers, because really web fonts can be a progressive enhancement when you're dealing with content fonts. Now, icon fonts are a completely separate thing. We can go into, I could do another 40 minutes about the difficulties with implementing font loading and icon fonts. We're not going to do that today. I would recommend that if you want to use icons on your site, to go with SVG, so you don't have to deal with all of these web font loading considerations with a completely different mechanism. So you just use SVG and then you won't have to worry about a lot of these font loading problems that come with icon fonts. So yeah, so the font face block that we can use nowadays is just two file formats, the WAF2 and the WAF format. And it's much simpler, much easier. And web browser support is actually really good for this format stack. use WAF2 because the compression, so in both WAF and WAF2, the compression is built right into the file format. You don't need to worry about any server configuration or compression headers to set. It's all built into the files, so you can just go ahead and use them. And in some cases, you might be able to get away with just using WAF2. You need to look at your the browser support that you want to deliver for your site, but WAF2 support is really pretty good right now. For my stuff, I still use WAF and WAF2. All right, so we talked a little bit about font face syntax. Let's talk about strategies that we can use to make our web fonts load faster. So let's go back to our buddy Mitt here, our Mitt Romney problem, the Mitt Romney web font problem. I love calling it that, so we can blame him for that problem. So yeah, he had 2 web fonts. The site was 2 web fonts on the site, title in Gothic and a title in Gothic italic. And so you might be able to guess what happened here. Each web font has its own independent loading lifecycle. So each web font has its own 3-second timeout, its own flash of invisible text, its own flash of unstyled text. So in this case, the normal or Roman style, the non-italic style loaded first. And the italic web font was still loading. It was still flash of invisible text here. So nothing was showing when it wanted to render that not to the screen. So the easiest thing we can do to fix this is to add, there's this great new CSS descriptor that we can add to our font face block. It's called font display. And if you use the swap value there, it will basically emulate, or it will basically force the web browser to use a flash of unstyled text for everything. So that's kind of it. So congratulations, we did our first font loading strategy. Yay. I can't hear if anyone's cheering, so I'm assuming the crowd's going wild with this one simple, tiny little font display descriptor. And the browser support is actually pretty good for it. It's in Chrome, it's in Firefox, it's in Safari. Not quite in Edge yet, but I assume it's coming soon. And the great thing about this is that it eliminates all the race conditions that we had for this problem, the Mitt Romney web font loading problem. So if we look at both mechanisms, so each individual path that our web fonts can take, on the left you can see the behavior that happens when the regular font has loaded first. So our regular font renders. The web font is showing in green there with the green check mark. And then the fallback font renders in the italic. So it doesn't matter which font will load first, you'll always have readable text and you won't have incorrect, inaccurate headlines presented to your users. So that's great. That solves our race conditions there. We don't need to worry about which web font's going to load first, but your web fonts might still appear to be slow because the fonts are still loading at the same time. You've just made them visible while they're loading. You've changed the perceived performance of the page. You made the text instantly readable, but it didn't actually make the web font rendering happen any faster. So to learn about why this happens, or to learn about things that we can do here, we need to know what checklist, what criteria must a web browser meet before it actually starts to download a web font. So first, it's got to parse your CSS, it's got to find your font face blocks, but it also has to find nodes in the document that use your font family that matches in your font face block, that are not empty. They have to have text content in almost all cases. And if you're using a Unicode range on your font face block, that needs to match with your text content as well. And the reason browsers do this is a performance optimization, right? So my favorite example of this is New York Times at one point had 191 font face blocks in their CSS. They just dumped a ton of web fonts on their website. And I went back and checked last night, and they're down to 110. Congratulations. The trend is improving. But it's because web browsers have chosen to sort of use this performance optimization, it's not a huge deal because web browsers only load web fonts that are used in content on the page. So it's not the end of the world that this happened, but it's definitely a performance optimization that they could improve. And I guess they are improving slowly. So the problem here So web browsers have sort of worked around this problem with sites dumping a bunch of font face blocks on their page. But the problem is the browser doesn't know to download fonts until super late in the waterfall. Web font requests often don't start until right before your website's about to render, which is not great. It's really bad. That's why you see a lot of invisible text if you're browsing around on a slow connection. So the one thing that we can do to work around this is to use preload. So preload is a hint to the browser to tell it to download it higher in the waterfall. To download it, it tells the browser we're going to use this resource later on, and you should download it ahead of time. And to do this, it's really just a simple link element you can add to your head. Preload, and you can preload a bunch of different kinds of things. You can use CSS, images, JavaScript. In this case, I want to preload my WAF2 format. And you want to use WAF2 here because all browsers that support preload also support WAF2. But really, this will cause your web fonts to be downloaded quicker, higher up in the waterfall, and it'll work a little bit better. Your web fonts will render sooner. So we kind of went through two different things that you could do: font display and preload. Those are very easy things, a CSS thing and an HTML thing. But let's do a little bit more. Let's go a little bit further. So there's another strategy I want to talk about today, and this is the Fout with a class strategy. And this uses a little bit of JavaScript. So in this example, let's just assume that we have two font face blocks, normal Lato and then a bold Lato. And using something that's known as the CSS font loading API, we can use code to sort of hide our Lato usage in our CSS behind this fonts loaded class, behind the fonts loaded class. So we only use the Lato font family inside of this sort of guarded fonts loaded class on top. And then we use the CSS font loading API below to add that class to our document when our fonts have successfully loaded. So we programmatically trigger, using JavaScript, using the CSS font loading API, the load of our two web fonts, document.fonts.load. And then when those have loaded successfully, that's when we render those to the user using this fonts loaded class. So we trigger that usage of Lato on when the fonts have successfully loaded. And the browser support for this is pretty good. Not in Edge yet, but hopefully it'll be coming soon. If you want in Edge right now, you can use polyfill. You call it Font Face Observer. There's the URL for that. And again, I'll put these slides online so you don't need to write this down. We'll have access to these resources later. But the great thing about this approach is that there's no flash of invisible text, which, all right, fine, we can get that from font display, so that's not a great new thing. But it works with third-party hosts. So Google Fonts, for example, notoriously doesn't work with font display, but this Fout with a class approach will. But really the big one is that you can group repaints together. So if you're using multiple web fonts from the same font family, you can group those repaints so they all render at the same time. And that's huge because you don't want, if you're using 3 or 4 or 5 web fonts on your page, you don't want every single web font render to sort of cause your page to jump around. Yeah, so that's kind of a little bit janky there. So we can work around that using grouped repaints. And sort of the downfall of this approach is that you don't want to use your Lato font family outside of that guarded class. It'd be very bad to just dump Lato inside of a body block there, for example, because that would trigger a load of Lato earlier than you want to. So you have to manage all of your font family use very meticulously. Well, sort of. So there's a plugin you can use, Post CSS FOF classes. You can use this to process your CSS for you automatically. And I wrote this and I based it on a plugin that Netlify put out. Very great Post CSS plugin. And it will process your CSS for you automatically. So you can just use your web fonts in your CSS as you normally would, and it will transform those for you with whatever fonts loaded. If you want to change that, you can change that. But it will hide your font family usage behind that guarded class for you. So yeah, it works great. So let's go back to some rocket science, right? Has anyone heard of the Big Dumb Booster? Amazing, awesome, great. Big Dumb Booster. It's actually an aerospace engineering principle that I think might actually be kind of applicable to how websites are built today. And it states that a bigger, dumber, and simpler rocket is often cheaper to build and operate than a smaller, more efficient, and more complex rocket. And I kind of like that, but again, it's irrelevant because web fonts are not rocket science. Okay, I want to go through a couple of things real quick here at the end. I want to talk about font subsetting. So we talked about how to make our fonts load quicker, higher up in the waterfall, how to render them while they're loading. But really another great thing you can do is to reduce the number of glyphs that are inside your web fonts. Make your web fonts smaller. So we talked about compression, WAF and WAF2 formats. Those can make web fonts smaller. But the other thing you can do is to just remove things from the web font content or from your font files. Assuming that your internationalization and language and licensing requirements allow it. Some fonts don't allow you to subset, so you need to make sure that your license works with that. And so I have a tool to do this called Glyphhanger. You can check it out. It's on the Filament Group GitHub. It's actually pretty easy to use if you are familiar with the command line. The standard thing that it does, it will go out to a website, find all the characters, the Unicode range that's used on that website, and it will spit it out to you. So I'm just running this against my website, and here's the Unicode range for all the characters I use on my website on this homepage. And you can also output the string as well. This is what it renders like in the console. But the nice thing about Glyphhanger is that you can also automatically subset web fonts here too. So you just feed it a glob of files here for your web fonts using this -- subset, and it will automatically transform these files and convert them to WAF, WAF2 formats that you can use right in your pages. And it's really a huge amount of savings too. So this example that I ran is my website, reduced the number of glyphs by a lot, but really with this compression, with all 8 variations of this font, it went from 1.14 megabyte down to 93 kilobyte after using WAF2 compression. So it's a huge amount of savings. So it's a big deal. And you could pass your own whitelist into if you want to subset without using any sort of spidering content. You can just pass your own strings or Unicode range right into it. So it's a great, easy way to subset web fonts. And this is great because smaller font files load faster. We want to reduce our Flash invisible text that will reduce your Flash at 1 style text. We want to get our web fonts rendered to the user as quick as possible. And so the last thing I want to talk about before we do questions is variable fonts. So variable fonts is the great new, it's the new hotness in web fonts. It's amazing. Everyone's excited about it. I'm super excited about it. Variable fonts are awesome, and I'll tell you why. So before, you might have had 8 different variations, 8 different styles of a web font loading on a page. So in this example, San Francisco, we have 8 different weights loading here. The great thing about variable fonts is that we can combine all of those weights into one single variable font file. And then it uses math to sort of interpolate the different weights for you automatically. So you only need to load one thing, and you get all of the, like a huge number of weights built in. A great resource for playing around with this is called Access Praxis. You can check access-praxis.org for this. And you can see the little slider going back and forth. It gives you a ton of different font weight variations that you can use here. But the really amazing thing about variable fonts is that you can have any number of axes built into a variable font. And font authors can sort of customize those. So it gives us it gives web authors a ton of power to sort of render web fonts how we might want them to be rendered, and truer to how the author might want them to be rendered too. And browser support for this is actually really pretty good. Firefox behind a flag, it's kind of lagging behind here, but it's coming, and it is available in Edge right now, so it's great. The only downside here with variable fonts is that you're paying for this extra math with kilobytes of content. So just as a simple example, we have Source Sans Pro with 3 different variations here, Roman, Light, and Bold. That weighs about 116 kilobytes, and WAF 2 when you add them together. And the variable font is about the same size. So if you're only using a single font weight or a single axis on your website and your rendering, you really might not get a great benefit out of using a variable font. But if you're using 3 or 4 or 5 different variations of a web font, that's when you're going to get a real great benefit from using a variable font. But the thing I'm super excited about, the thing that's really great about variable fonts, I think, is that they force grouped repaints. All your web fonts are going to render at the same time. So we don't need to do sort of this more complex JavaScript stuff built in. It's built in right into the font format. So using variable fonts, using font display, using preload, a lot of these race conditions that came with Mitt Romney's web font loading problem go away. All right, so I guess it's the end of the presentation. I don't know if web fonts, I don't know if I've convinced you that web fonts are rocket science or not. Hopefully you are maybe closer to thinking that they aren't than when we started. I do have just a checklist at the end that I want to go through super quick. This is just the things that we want to think about when we're font loading. We don't want invisible text. We want unstyled text. We want to reflow as little as possible and as soon as possible. We want fewer repaints. We want to group them. We want to trigger our downloads sooner. We want to make our font files smaller. And these are the things that we can do to achieve that. Font display, CSS font loading API, variable fonts, preload, WAF 2 compression, and subsetting. Really, really great tools at our disposal. And we're really at this great point right now because a lot of these approaches are not JavaScript, or without JavaScript. You don't have to use JavaScript to use them. So if you want to read more information, I have a comprehensive guide to font loading strategies on my website. It's a giant blog post. There's another version of that coming out later this year. And then I have a bunch of demos on this GitHub repo, web font loading recipes, so you can check out actual demo code. All right, so just a quick thank you to all the people I look up to and the people that have helped me develop this presentation. Follow them on Twitter, and thank you.
Thank you, Zach. Thank you for that informative session.
Yeah, you're welcome.